So the integral test for convergence states that so f of x is a positive decreasing continuous function on the interval k to infinity with fn equal to an. Then the series summation n equal to 1 to infinity is convergent if and only if integral k to infinity f of x dx converges and summation n equal to 1 to infinity an is divergent if and only if the integral k to infinity f of x dx diverges. So here k will be so we have f of n equal to an. So k will be the n value from which f of x is positive, decreasing and continuous function. So this integral must either, so if it is finite, then we say that the series is convergent. So if it is infinite, it is said to be divergent. We need to now check the convergence of summation n equal to 1 to infinity 1 by n raised to 1 by 5. So here f of x will be equal to 1 by x raised to whole power 1 by 5. So as we can see, when k varies from, so here n varies from 1 to infinity. So when n is varying from 1 to infinity, the function value will be positive. So if we take f of n will be always positive. So f is positive, and when x increases, f of x value will be decreasing because it's in the denominator. So f is decreasing, and f is continuous. The only point of discontinuity is x equal to 0. Now we are considering only the n values which are greater than 1. So f is continuous. So it is positive, decreasing and continuous. So by integral test, this is positive, decreasing and continuous for n greater than or equal to 1. So by integral test, we'll evaluate integral 1 to infinity f of x dx. So that will be 1 by x raised to 1 by 5 dx. So the integral will be x raised to minus 1 by 5 plus 1 by minus 1 by 5 plus 1 from 1 to infinity. So that will be x raised to 4 by 5 by 4 by 5 from 1 to infinity. So at infinity, the value is going to be infinity. So therefore, the value of integral is infinite. So therefore, by integral test, summation n equal to 1 to infinity 1 by fifth root of n. So this will diverge. So this diverges. Second problem, we need to check the convergence of summation n equal to 1 to infinity 1 by 2n plus 1 whole cube. So here f of x is equal to 1 by 2x plus 1 whole cube. So when x is greater than or equal to 1, so this will be positive. Now we have x value in the denominator. So as x increases, f of x is decreasing. So it is positive, decreasing, and the only point of discontinuity is minus 1 by 2. So that is not in the portion x greater than or equal to 1. So it is continuous. So it is positive, decreasing and continuous for n greater than or equal to 1. So by integral test, we need to evaluate integral 1 to infinity 1 by 2x plus 1 whole cube dx. So this will be integral 1 to infinity 2x plus 1 whole raised to minus 3 dx. So value of integral will be 2x plus 1 whole raised to minus 3 plus 1 is minus 2 by minus 2, and this 2 will come. So 2 from 1 to infinity. So that will be minus 1 by 4 2x plus 1 whole square from 1 to infinity. So we will get here at infinity we will get 1 by infinity is 0 minus at 1 we'll get minus 1 by 4 times 2 plus 1, so that is 3 square is 9. So the value will be 1 by 36, so which is less than infinity. So therefore the series converges by integral test. So the integral value is finite, so the series will be convergent. And next question, we need to check the convergence of summation n equal to 1 to infinity 1 by root n plus 4. So we'll take f of x as 1 by root x plus 4. So this will be positive, f of x is positive. Now as x increases, f of x decreases. So this will be decreasing, and the only point of discontinuity is minus 4. So minus 4 is not in the region, so it will be continuous. So it will be positive, decreasing and continuous for x n greater than or equal to x greater than or equal to 1. So by integral test we need to evaluate integral 1 to infinity f of x dx. So that will be integral 1 to infinity 1 by root of x plus 4 dx. So that will be integral 1 to infinity x plus 4 whole raised to minus 1 by 2 dx. So the integral will be x plus 4 whole raised to minus 1 by 2 plus 1. So that will be plus 1 by 2 by 1 by 2 from 1 to infinity. So at infinity the value will be infinity, and at 1 we'll get 5 raised to 1 by 2 by 1 by 2. So the value is going to be infinity. So therefore the series diverges by integral test. So the series will be divergent. And next problem we have summation n equal to 1 to infinity n plus 2 by n plus 1. So we can write this as summation n equal to 1 to infinity. So n plus 2 can be written as n plus 1 plus 1 by n plus 1. So this will be equal to summation n equal to 1 to infinity 1 plus 1 by n plus 1. Now if we take f of x, so f of x will be 1 plus 1 by x plus 1. So this is positive, and as x increases 1 by x plus 1 is decreasing. So f of x will be decreasing, and the only point of discontinuity is at x equal to minus 1. So it is not in the region of integration, so it will be continuous. So this will be positive, decreasing and continuous for x greater than or equal to 1. So we will evaluate integral 1 to infinity 1 plus 1 by x plus 1 dx. So integral of 1 will be x, and integral of 1 by x plus 1 is log x plus 1 from 1 to infinity. Now at infinity x and log x will be infinity, log of infinity will be infinity. So the value will be infinity. So by integral test the series diverges since the integral is infinite. This problem we need to evaluate check the convergence or divergence of summation n equal to 1 to infinity n raised to minus 1.4 plus 3 n raised to minus 1.2. So here f of x will be x raised to minus 1.4 plus 3 x raised to minus 1.2. So that will be 1 by x raised to 1.4 plus 3 by x raised to 1.2. So when x is greater than or equal to 1, this will be positive, and as x increases, since x is in the denominator, function value will be decreasing, and the only point of discontinuity is x equal to 0, so that's not there. So it will be continuous. So it will be positive, decreasing and continuous for x greater than or equal to 1. So we will evaluate integral 1 to infinity f of x dx. So that will be integral 1 to infinity x raised to minus 1.4 plus 3 x raised to minus 1.2 dx. So the integral will be x raised to minus 1.4 plus 1 by minus 1.4 plus 1 plus 3 x raised to minus 1.2 plus 1 by minus 1.2 plus 1 from 1 to infinity. So that will be 1 by minus 0.4 x raised to 0.4 will come plus 3 by minus 0.2 x raised to 0.2 from 1 to infinity. So at infinity both terms will get 1 by infinity, so which will be 0, and at 1 we'll get 1 by minus 0.4 plus 3 by minus 0.2. So the value is less than infinity, so it is finite, so therefore the series converges by integral test. And next problem is summation n equal to 1 to infinity 5 minus 2 root n by n cube. Now if we take 5 minus 2 root n, this will be greater than 0 only if 5 is greater than 2 root n. So upon squaring on both sides, we will get 25 greater than 4n. So we must have n less than 25. So here if we take f of x equal to 5 minus 2 root x by x cube, it is not positive for some x greater than or equal to k. So it is not positive for all x greater than or equal to k. So therefore the integral test cannot be applied in the case of the series. So the integral test cannot be applied. So we cannot determine whether the series converges or diverges by integral test. Next problem, we have summation n equal to 1 to infinity n square by n cube plus 1. So here f of x is x square by x cube plus 1. So when x is greater than or equal to 1, this will be positive, and there are no discontinuities when x is greater than or equal to 1, so this will be continuous. And in order to check if it is decreasing or not, so if we take f dash of x, f dash will be x cube plus 1 whole square, then x cube plus 1 into derivative of x square will be 2x minus x square into derivative of x cube plus 1 is 3x square, so that will be 2x raised to 4 plus 2x minus 3x raised to 4 by x cube plus 1 whole square. So we will get 2x minus x raised to 4 by x cube plus 1 whole square. So that will be x into 2 minus x cube by x cube plus 1 whole square. So whenever so if x is equal to 1, in that case we will get a positive value, that, and whenever x is strictly greater than from 2 onwards, so if you take take x greater than or equal to 2, f dash of x will be less than 0, so that is f is decreasing for x greater than or equal to. If x is equal to 1, this is positive, so in that case it will be increasing. So the function will satisfy all the three conditions when x is greater than or equal to 2. So we will take integral 2 to infinity f of x dx, so that will be integral 2 to infinity x square by x cube plus 1 dx. Now using the substitution, u equal to x cube plus 1 du is equal to 3x square dx, and x varies from 2 to infinity, so u will vary from, so 2 cube plus 1 will be 9, so 9 to infinity, so we will get the integral as integral 9 to infinity. So x square dx will be du by 3u, so that will be 1 by 3 log u from 9 to infinity. Now log of infinity will be equal to infinity, so the value of integral will be infinity, so therefore the series diverges by integral test.